Alright, kiddos, attempt number 25 at making this video. So first off, I want to give a big thank you to Ms. Thomas, our substitute today. Thank you so much for being here. But without further ado, let's get started. Students, by now you should have your notes glued in and your notebook ready to go. So I'm going to scroll down to Table of Contents. Please make sure you're filling out your table of contents as well as completing your page numbers. There will be a notebook check next class, so please fill in your page numbers. Ms. Thomas, if you could pause the video here for about 5 minutes to give the students time to fill this out, that would be wonderful. So pause here. Alright, hopefully that should have been enough time to fill out your table of contents. If you're not done, this video will be available for you on Schoology, so you can watch it again and pause at any time you need, including right here at the table of contents. But for now, I'm going to keep going. So, if you are in one of my even periods, if you are in one of my odd periods, today is Monday, April 8th. If you are in one of my even periods, today is Tuesday, April 9th. This is the last class we have before y'all take your topic test. So again, the last lesson right before our last test. So just a quick reminder, we have no school on Wednesday, April 10th. And then the next time you have this class, y'all be taking your topic test. So odd days, that will be April 11th. Even days, that will be Friday, April 12th. And again, I will be checking your notebook next class, so please make sure your notebook is complete with page numbers in your table of contents. And the golden notebook is available for you to fill in whatever days you might have missed. Let's move on to some notes. So we're going to start off with cross sections of solids. And a cross section is the intersection of a solid, a 3D shape, and a plane. So y'all can see here that we have these 3 cubes, these 3 solids, and we're cutting them with planes in different ways. So a quick review, a plane is a flat surface that extends forever. So above, when I cut my cube with a sort of like a horizontal plane, a like horizontal slice, I get a square. When I cut my cube along that diagonal, it makes a rectangle. Or if I cut my cube at like just cutting off the corner, we get a triangle. So there are different ways to describe how we're cutting with that plane. We could cut at an angle. That's called an angular slice. We could cut parallel to the base. That is a horizontal slice. Or we could cut perpendicular. Again, perpendicular is 90 degrees. So we could cut perpendicular to the base, which is a vertical slice. So kind of looking down at the next section, in option A, you see that we have this hexagonal prism, and we are making a vertical slice. We're cutting straight down, and the shape that is created is a hexagon. So I know I'm going to match option A up with hexagon down here. Now I want to give y'all 30 seconds to try and match up the rest of these yourself. So I'll start talking now. Go. All right, that was about 30 seconds. As I check your notebook, I'm going to be checking to make sure that you actually tried this problem on your own, so please make sure you fill this in. Right now, we're going to move on to talk about solids of revolution. So you can see in the picture down below that I have this rectangle, and I'm trying to kind of rotate it around this line. So a solid of revolution is a 3D shape that we get by rotating a 2D shape, like this rectangle, around a line, around an axis. And that line that we're rotating around right here has a special name. It is called the axis of revolution. So now, moving down here, what I want y'all to do is try and imagine what type of shape we get, what type of solid, what type of 3D shape we get when we rotate these 2D shapes around that line. So again, I'm going to pause and give you 30 seconds to answer these two questions. Go. All right, that was about 30 seconds. So in this first one, I know what I'm doing is rotating this rectangle around. So if I'm spinning it around, that means I'm kind of making a circle. So I'm making a circle with this side and a circle with this side. And when I imagine like I rotate that rectangle, the shape I get is a cylinder. Again, here I'm imagining I'm rotating this triangle. So we're going to move this bottom side around in a circle. And when I connect to my point, the shape I get is a cone. All right, so now moving on to this last section down here. I want you to imagine that the axis of revolution is going to be at x equals 0. So when I'm looking at my x-axis down here, I know x equals 0 is going to be right here. And this line, this vertical line that I have, is the line x equals 0. So what I want to do is rotate my shape. But what you might notice here is that we have a little bit of space between our shape and our axis of revolution. So when we rotate, we're going to keep that little bit of space, right? But instead of it having that little bit of space on one line, we have a little bit of space all the way around. So let me erase that. So you can see that we end up with this hollow section in the middle of our 3D solid. All right. So that right there is the end of the notes. Hopefully this made sense to you. If not, please, please, please go back and watch this video again. It will be available on Schoology. If instead you might want to read about it, feel free to pull a textbook off the shelf. Cross sections of solids is chapter 12.1. Solids of revolution is chapter 12.8. I tried to save an easier lesson for the sub. So again, if you're still struggling with this, please, please, please feel free to send me a message on Schoology. Right now, I'm going to have y'all work on an assignment in Big Ideas. So because this is kind of a short video, you should have a little bit more time to get going. So this assignment is 15 problems. 10 of the problems will be about what we learned today. And the other 5 will be review problems to get you ready for your topic test next class. Also, after you are done using the computers, please make sure that you are putting the computers back in the cart and matching up the number of your computer to the correct numbered slot and plug in that computer. Please save Ms. Thomas a little bit of work there. Hopefully this video was okay. I'm sure there are some sound quality issues, and I'm still working on sort of the skill of presenting information as a video. But y'all have a great class. Message me with any questions. All right. Bye.